All right, today we're going to talk about law of sines, which is section 9.2. It's not that bad, but I'm sure it's still going to be a little bit longer than I would have anticipated it to be. There are 29 homework questions, okay? And we'll talk about which ones are which. So law of sines is law of sines and law of cosines, which is coming up in section 9.2, are both ways for you to find side lengths and angle measures in oblique triangles or triangles that are non-right triangles. You've used right triangle trigs, sine, cosine, and tangent a lot in geometry and also earlier this year, but now we're going to talk about law of sines and law of cosines. So there's two forms for law of sines. There's one where the side lengths are on top and then sine of the angles are in the bottom of each fraction. This is what I would call an extended proportion. And then the other version is when the sine of the angle is in the numerator and the side lengths are in the denominator. I usually use this. I mean, they're interchangeable, and it really doesn't matter which one you use. You can choose to stick to one if you wish, but normally I use the first one when finding side lengths, just because it's easier to keep it in the numerator, and then I use the second one when finding angle measures. That's really the best thing to do. Okay, so there's a table on this first page about when you can use law of sines and when you can't use law of sines. So these first three right here, descriptions about triangles, and I know basically are talking about when they talk about side angle, it's talking about the information that's known. Like maybe in the first picture you have two angle measures known and one side that's opposite one of those. So these first three ways of information that you have, you can all solve using law of sines because you have enough information that you can plug into that extended proportion up in the box and figure out what the missing information is, because it's always going to give you something that you could figure out. The next two are generally used for law of cosines, and I don't know if any of the homework questions are going to ask you if you can use law of cosines or not, but generally you use law of cosines when you have side angle side given or side 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 given. And then if you actually have three angles given, then this presents no unique triangle at all. So just means that like if I give you three angles and no sides at all, then you can't really figure out if there's anything in particular that's going on there. Okay, so moving on to the next page. Homework numbers 1 through 6 are going to ask you to determine whether or not the triangle can be solved using law of sines. Okay, and then it'll give you a list of different reasons, and you can see the list is going to look something similar to the list that you see in this particular example. This is what we mean about the information that we have. Notice that we have an angle and another angle and a side that's opposite one of those angles. So because, like if you're looking up here, because you have two angles and a side that's opposite one of those angles, you can solve it using law of sines. So this is a yes. And then you got to go through your reasons for yes. So you're looking at maybe this one or this one or this one, any place where it says yes. So it says yes because two angles and a side not opposite. That's actually not going to be law of sines because we do have a side opposite one of those angles. And so the second one says yes because two angles in the side opposite one of those angles are given. So this is the one that we're talking about right here for number 1. There's two more examples at the bottom of this page right here. So but what I'm going to do is just like look at this information and then scroll back up to the list a little bit. In problem number 2, we have an angle given and another angle given and another angle given, and I'm talking about the measures. You know, three angle measures. Three angle measures presents no unique triangle. So I'm going to look at that list and see which one says no unique triangle or that you have three angles or something like that. So at the top of this list, when I'm looking for no unique triangle, it says something like no because three angles are given. Do not define a unique triangle. So that would be my answer for number 2 that's at the bottom of this page. Okay. And then for number 3, this is the information that we have. We have a side known, and then we have another side known, and then we have the angle that's in between. This is called side angle side. This is going to be used for law of cosines if you look at the previous page. So we'll use this eventually in the next section, but it's not using law of sines, okay? So be careful. This is not law of sines a little bit, so watch out for that. And then the reason for this problem number 3 right here is going to be something, let's see. It's not going to be no because no angles are given. It's going to be no because there's no angle with an opposite side given. No angle with an opposite side given. So this will be the correct answer for number 3. I probably should have put that in purple, but no. This will be number 3 because there's no angle with an opposite side given. All right, we're going to move along to the next question on the next page to address some others a little bit. Okay, so we're going to use law of sines to solve some of the triangles that are not right triangles. Sorry. Going to pause for 1 second so I can choke. Okay, I do want you to pay attention to this note right here that says whenever possible, we're going to avoid using rounded information. So be careful about that. I try to use that answer key on your calculator as much as possible. Remember that that's the answer key on your calculator looks like the negative sign in parentheses. It's at the bottom and it's next to your enter key, and it has a little ANS above it. I'll try to use that as often as I can, and sometimes in a problem I'm going to write ANS, which means that I'm just taking the answer that's already in my calculator. One of the things you want to watch out for in this section and all of the sections in this particular chapter is don't clear your calculator very much. When you get an answer and then you might have to use that answer to get something else, then you should just write it down and move on to it a little bit, and then go forward from there. Okay. So in this very first problem, here's what we're going to think about. If it's useful for you to draw a triangle, then by all means draw a triangle. It's not a requirement if you don't want to, but if you want me to, I'm just going to go ahead and draw one, and I'm just going to put in some information. It doesn't matter really how you draw it. That's completely up to you. So I'm going to put I'm going to call this C and B and A. So I'll put 52 degrees right here, and then this will be 46 degrees. It's hard to get it to come out okay, and then this will be 7 meters. It is absolutely not necessary if you don't want to draw the triangle. But notice we're going to have to figure out, here are the things that are missing. We are going to have to figure out what is the measure of angle A, and we're also going to have to find side B, and we're going to have to find side C. So all of those things are missing. The easiest thing for us to find is the measure of angle A. Why is that? Because we already have 2 angles in the triangle known. So angle A is going to be equal to 180 minus angle C and minus angle B. So 180 minus 52 minus 46. If you want to add them first and then subtract, it doesn't matter to me. It's all okay. You can totally do that, but the measure of angle A is going to be 82 degrees when you solve for that. So we already have one answer. That's 82 degrees. Now we got to find side B and side C. So again, like if I want to find side lengths, then the form of the law of sines that I'm going to use has the side lengths on top. So I'm going to say A over sine A equals B over sine B is equal to C over sine C. And I'm going to plug in everything that I know to this formula. So I'm going to put 7 over sine of, remember we just found out that A was 82 degrees, equals B over sine of, and angle B measures 46 degrees, equals C over sine of 52 degrees. All right, here's one other thing that you definitely want to watch out for. This is the one ratio that you have both the numerator and the denominator. That means this is like the key that unlocks the door to helping you find side B and side C. So I'm going to set up 2 different proportions, and I'm going to say 7 over sine of 82 degrees is equal to B over sine 46 degrees, and I'm going to say 7 over sine 82 degrees equals C over sine 52 degrees. And I'm going to solve each of these for side B and side C. If you want to cross multiply and then isolate that way, that's fine, but notice like B is already in the numerator here. So if you just multiply both sides by sine of 46, on the top, then that's going to cancel it out on the bottom here, and you're left with 7 sine of 46 degrees over sine of 82 degrees is equal to B. Okay, now you're ready. This is kind of what I would call like a calculator ready answer, and you're ready to type it into your calculator. I would suggest getting calculator ready answers as much as possible before you type it in. Remember that your calculator, when you press the sign key, it's going to open parentheses automatically. And it is absolutely imperative right here that you close the parentheses behind the 46 before you divide by the sign of 82. It's going to open it again around the 82. Obviously, if this is the last thing you're typing, then it's not going to matter if you close it, but if it's going to make you feel better, then go ahead and close that 82 and then type in your answer, 7 sine of 46, close the parentheses, divided by sine 82, close the parentheses, and B is approximately 5.1. I think in the directions that it did maybe say to round to 1 decimal place, so that's where I got that from. Please make sure that you're paying careful attention to the directions. Sometimes it's going to say 1, sometimes it's going to say 2. Now we found the value of B, that was 5.1. We're going to repeat that process all over again to find side C, so we have sine of 52 times sine of 52 on both sides so that you can cancel it on the right. 7 sine of 52 degrees divided by sine of 82 degrees is equal to C. Don't forget that when your parentheses get opened when you type it in, that you definitely have to close those parentheses behind the 52 before you divide. And then you can do it there as well. And then you're going to type in 7. You don't have to type the time sign if you don't want, but 7 sine 52, close the parentheses, divided by sine 82, and then close parentheses, and that should give you 5.6. So one thing that you may want to do when you get your answers is see if they make reasonable sense. You may have actually forgotten from geometry that in a triangle, you should remember that the longest side should be opposite the largest angle, okay? And so forth and so on. Like the smallest side should be opposite the smallest angle, and the middle side opposite the middle angle. So if your numbers are not coming out right, when I look at the information that was given for angle C and angle B and angle A turned out to be the largest angles. So side A should be the longest side, and according to the values that I found, that does actually work out. I know you don't want to hear this. Yesterday I tried making a video, and then of course I didn't have my calculator in degree mode. Please make sure your calculator is in degree mode and not in radian mode. For this whole entire chapter it needs to be in degree mode, because yesterday I was trying to do the video and it I didn't have my calculator in the right mode, and then had to go back and redo everything. So alright, moving on to the next one. This one would be like homework problems. Let me see if I can tell you. This would be like homework problems number 13, number 11 through 13. I'm sorry, I'm lying. I'll take that back. This will be like homework numbers 7 through 10. All right, and then I'm going to move on to the next page and talk about the next type of problem. So before we get to the next example, on this particular page where it gives you a chart about the value of sine B, here's what's going to happen. Using law of sines, there's situations in which you might have more than one triangle. And we'll talk about it in just a minute, but here's a couple of things to pay attention to. Some of your homework questions are going to ask you, leading up to getting you to solve some stuff, it's going to ask you to calculate the value of sine B first. So if the value of sine B is greater than 1, then there is no triangle. All right, and if it's equal to 1, then there is one right triangle. That obviously B would be the right angle. And then if the value of sine B is between 0 and 1, then you might have 1 or 2 triangles. And it's just going to kind of depend a little bit on the information. But here's what you kind of need to watch out for. looking at this picture, and it's not gonna make a lot of sense to you right now, but it will when we work another problem, so you just may want to back up a little bit. I don't think this one is the one that you're gonna need too much right here. Maybe, we'll see. But here's what I want you to pay attention to. Imagine a little bit that this triangle and this triangle are basically one and the same in a sense. You have some constant information here, and the constant information is the length of this side B and the length of this side. Sorry, my bad. That's not true. Not the length of this side. And this angle right here, angle A, and then the length of this side over here. So that's the constant information, and I want you to just kind of pretend that this side is like on a swinging, it's like a door kind of hinged up here at the top, and if it can swing over here and become over here, then it looks like this picture down here, okay? That's really what's happening. So this triangle, like this triangle is not the triangle that's really being used at all. What's happening is we're talking about using, I'm gonna highlight them for you, this triangle right here, which might just be one triangle, and then you also have a scenario where you might have this triangle down here, okay? And then you have different cases where you have an angle B sub 1 and an angle B sub 2 and a C sub 1 and a C sub 2, and then it gets a little sticky. So here's angle B sub 1. This would be angle B sub 2 in here. This whole entire angle is C sub 1, and this little bitty angle is C sub 2. And this little side is the big side is C sub 1, and then the itty bitty side is C sub 2. And that's going to get a little confusing. I know you don't understand what I'm talking about just yet, but just watch and see what happens. Okay, so on the next example, this is number 13 over here on the next page. This will be like homework questions, numbers 11 through 13. It also actually will include a little bit for homework numbers 14 through 19. You are not asked for sign B first, but you kind of still need to figure that out. You need to figure that out in order to be able to answer those questions. Okay, so we want to find the value of sign B. Again, I'm going to set up, since I want this value sign B, I'm going to put that one in the numerator. So I'm going to say sign A over A equals sign B over B, sine of 40 degrees over 8.1 equals sine B over 7.3. And I'm going to multiply both sides. Sorry, that looks terrible. I'm going to multiply both sides by 7.3 to get it out of this denominator. Times 7.3. And when I type it into the calculator, the way that I'm going to type that in looks like this. I'm going to type in 7.3 sine of 40 degrees divided by 8.1, and that's going to be equal to sine B. And when you type it in, don't forget that you need to close the parentheses behind that 40 degrees. That's going to be imperative. Okay, so when I calculated sine B, I got approximately 0.5793, and I'm not sure, I can't remember in the homework what it actually asks you for, but you're going to get I'm going to get 0.5793. If you find a mistake in some of these notes, then you definitely need to bring that to my attention, and I'll deal with that a little bit. Notice that because 0.5793 is between 0 and 1, that looks like this from the page on the previous chart. Sine B is greater than 0 and less than 1. Then it must be 1 or 2 oblique triangles. Now, technically, there's a little bit of a way to get a hint about how this can go. But then here's what you're going to do next. Okay, so now you're going to try to figure out if you have one triangle or two triangles. So the next thing that you're going to do after you have sine B, leave that in your calculator and make sure that you still have this number sitting in your calculator that looks like this, 0.5793. And then I want you to press second sine. So remember that I want you to take the inverse sine of this answer. So if you press second sine and then second and the negative key, which remember is answer, then it's going to take the inverse sign of this number. And what you're going to get is you are going to get, ooh, did it ask? Okay. So we're going to get the value of B to be approximately 35.4 degrees. Okay. And here comes the hard part. The hard part is you really don't know whether that means there's one triangle or two triangles. So what you're going to do is you're going to kind of quickly find out if there could possibly be two triangles right now. So here's how we're going to find out if there possibly are there two triangles. That's really what we're going to answer. To answer that question, we're going to say B sub 2 would be equal to 180 minus B and minus A. So what you would type in is you would type in 180 minus the answer that you have for B, which was 35.4, minus the answer, the value of angle A, which was 40 degrees. And you're going to get B sub 2. I'm sorry, take that back. Let's see if we can back that up 1 second. Okay, it doesn't really give me a good way to kind of go backwards. So you just have to erase where I was. To find out if B sub 2, to find out if there is a B sub 2, you're going to do 180 minus 35.4. And when you do that, you're going to get a B sub 2 value to be 144.6. This is not possible because 144.6 plus the 40 degrees for angle A is greater than 180, and you can't have a triangle be more than 180 degrees. So I'm sorry, like I just misspoke and needed to erase all that other stuff. So back it up. There's only one triangle, and angle B is 35.4 degrees. And then you're going to have to find angle C. To find angle C, you're going to do 180 minus angle A minus angle B. Remember, this is 40 degrees, and this is 35.4 degrees. And when you get angle C, you get 104.6 degrees. And now you're going to have to find side C. Okay? And in order to find side C, remember that you want to go back to the information that you had given, and you had sine of 40 degrees divided. I'm going to write it with the sides on top instead, excuse me. So I'm going to say the length of side A was 8.1 divided by sine of 40 degrees is equal to C over sine of, you could use the answer. I mean, I try to use the answer as much as possible. The answer that I'm talking about right here, this one, is the 104.6 degrees that we had right there. And then when you cross multiply and then solve that, you're going to get C to be, dang, I probably didn't type that in to figure out what that answer was going to be. So 8.1 times sine of the answer, or 104.6, divided by sine of 40. Don't forget to close parentheses behind the 104.6, or the answer. Divided by sine 40 would give me C is approximately 12.2. Okay, that makes good sense. If angle C is an obtuse angle, that side would be a lot longer. All right, we're going to move on to the next one, number 14. All right, again, like some of these are not necessarily going to ask you, so I'm going to set it up. Since I only have one angle and I'm going to have to find more angles, I'm going to put sine A over A equals sine B over B equals sine C over C, sine of 70.1 degrees over 21.5 equals sine B over 29.3 equals sine C over C. Sometimes it's not really going to ask you for every single thing. Sometimes it just might ask you like whether or not you're going to have a triangle, and it just might ask you to stop. So remember, I'm going to try to solve for sine B. I'm going to multiply both sides of this by 29.3. I'm just looking at the first two parts. This is supposed to be 29.3. So I'm going to type in 29.3 sine of 70.1 degrees. Don't forget to close the parentheses, divided by 21.5 equals sine B. So sine B is approximately 1.28. Notice that this is greater than 1. Okay, so use that table on the other page as a reference, right? Greater than 1. Therefore, since remember it said sine B, if sine B is greater than 1, no triangle exists. And then you're going to stop. And if there's multiple parts to that, then it should still be a choice that like no triangle, no triangle, no triangle is something that you could type in over and over and over again. You can try if you want, like if you don't remember that the sine B has to be greater, then what you can try to do, try taking the inverse sine. So try typing in inverse sine of 1.28, and you're going to get domain error, right? And that should tell you, remember that the values for sine and cosine have to be in between 0 and 1. Remember that the opposite side or the adjacent side can't be greater than the hypotenuse, and that's why that comes up a little bit, okay? All right, and in this particular problem, again, we're going to set it up. Since I don't have those sides, I'm going to say sine of 55 over 14. You're going to need a lot more space for this problem, is equal to sine of B over 16.3, excuse me, is equal to sine of C over C. So I'm going to multiply both sides by 16.3, 16.3. And now I'm looking at typing in 16.3 sine of 55 degrees divided by 14. And that's going to be equal to sine of B. Don't forget that the parentheses opens and you need to close the parentheses. I mean, more than anything else, you're more likely to make calculator mistakes on these types of problems more than anything else. So the sine of B is approximately 0.9537. This is between 0 and 1, right? So looking at that table, it kind of looks like this. So you should have 1 or 2 triangles. Now we're going to have to go about trying to solve a little bit. I think this was part 2. This is part 1. The other stuff when you're calculating sine of B up here. Okay. And then part 3, we're going to have to try to figure out like what is the value of the angle a little bit. So for part 3, I'm going to take the answer that's in the calculator and I'm going to do inverse sine of the answer. That's the 0.9537. I'm not going to type it in like that. I'm going to use the answer that's there so that I can figure out what B is. B is equal to this value. So B is approximately 72.5 degrees. Now you're trying to figure out if there's actually 2 triangles. If there are 2 triangles, then when you try to find B sub 2, and add it to angle A, then you should still have, it should still be less than 180 degrees, okay? So that's the kind of tricky part a little bit. Now you're trying to determine, is there a B sub 2? That's really what we're trying to figure out. If so, then B sub 2 is equal to 180 minus B sub 1, which would be this angle up here, the 72.5. So you would do 180 minus the answer, and you would get B sub 2 is approximately 107.5 degrees, okay? And so what you want to do is, like, if this is added to the original angle A, 55 degrees, is it still less than 180? And if the answer is yes, then you have two triangles. That's really what's telling me. So 107.5 plus the 55, that's only going to be like 62.5. So definitely there's still extra wiggle room that's less than 180. So you definitely have two triangles here. So just watch out for that. So it ends up that you do have a B sub 1 and you do have a B sub 2, and this is what you would type in. Okay, so part 4 of the problem is you need to find, part 4 is you need to find angle C sub 1 and angle C sub 2. Okay, so angle, and remember that's the capital letter. So capital C sub 1 is coming from 180 minus A minus B sub 1. So this was the 55 degrees. This was the 72.5 degrees. And when you type this in, you're going to get angle C sub 1 to be approximately 52.5 degrees. So now we've got angle C sub 1. Angle C sub 2 is going to be equal to 180 minus A minus angle B sub 2. So C sub 2 is 180 minus 55 minus 107.5. So angle C sub 2 is approximately 17.5. This is what I was talking about when you get that little skinny triangle on the left and then the larger triangle. So now you're going to have to do law of sines to find side C sub 1 and side C sub 2. So I'm going to set it up, and then you're just going to have to try to solve it and see. Remember that we started off the problem with sine, so this will be part 5. Part 5 is about finding side C sub 1 and side C sub 2. So you start off with sine of 55 degrees, which was angle A, over 14, which was side A. And now we know what angle C sub 1 is, so we're going to say sine of 52.5 over side C sub 1. And then you're going to solve, and you're going to get side C sub 1 to be approximately 13.6. After we did this, then we went on to part 4. Okay, and then we're working our way down. So side C sub 1 is 13.6, and then you're also going to have to find side C sub 2. So we're going to repeat that process again. Sine 55 degrees over 14 is equal to sine of angle C sub 2, which is 17.5, right? That was C sub 2 over side C sub 2. And when you solve this, you're going to get C sub 2 to be approximately 5.1. And that's side C sub 2. That's a side. So those, part 5 was sides, part 4 was the angles for finding C, and then part 3 was the angles for finding B. That's really a pain in the butt, but that's a whole big chunk of it right there. Okay? And then looking forward, I'm just trying to see what else there is. There's more problems. So that covered kind of 14 through 19 for the most part. And then you have, there's the ways that you can use law of sines, and then there's a word problem. So there's a couple of different word problems. The word problems are numbers 20 through 22. And I'll set this one up so that you can see what that one looks like, but also don't forget that you have mixed review, numbers 23 through 26, and then you're going to have reading assessment number 27 to 29. I know this is taking a long time, really sorry. Okay, so you can scroll down and see that again in just a minute. You want to determine the width of a river, and you've got markers on opposite sides. They're going to actually draw a picture for you, so it's going to be a little bit easier to see. I'm just going to kind of draw a river right here, okay, and you've got markers on opposite sides at point A and point B. So I'm going to put a marker at A. A third marker is placed at point C, 40 meters away from point A. All right, so I'm going to put C here. We don't know where B is, really. It doesn't say that B is directly opposite angle A, so I'm just going to put B right here. If the angle at point C is 42 degrees, so I'm going to say this angle is 42 degrees. And the angle in triangle ABC at point A is 112. Well, then that means that I didn't put my B in the right place. So I'm going to move point B over here because I need a bigger angle, okay? So I'm going to move point B over here in order to make this angle actually look like 112, I don't think you're going to have any of these issues because it's going to be in there, okay? This is the 40 meters right here. And then they want you to determine the width of the river to the nearest tenth of a meter. So that's going to be like, what is this right here? That's what's going to happen, okay? So in order to do that, we have to find angle B first because we have the side opposite angle B. So angle B is going to be equal to 180 minus 112 minus 42. So angle B is going to be equal to, that's 154. So that's going to be 26 degrees, okay? That's angle B. And then so that I can find the width of the river, which is opposite side C, opposite angle C, excuse me, I'm going to say x over sine 42 degrees, because x is opposite angle C, is equal to 40, which is the side opposite angle B, over sine of 26 degrees. And then don't forget, you're going to multiply both sides by sine of 42 so that you can cancel it on the left side. And then you're going to get x equals 40 times the sine of 42 degrees all over sine of 26 degrees. And then type that into your calculator and you're going to get the width of the river to be approximately, and I haven't typed it in yet, so 40 sine 42, close the parentheses, divided by sine of 26. The width of the river is approximately, and it says to the nearest tenth of a meter. Don't forget to read your directions, please. So the width of the river is approximately 61.1 meters. And that's the end of it. Don't forget that the mixed review and the reading assessment are down here at the bottom. I think in all of your word problems, there are actually pictures given, and I'm sorry that that took so long.